Greetings and welcome to Tutor. In the previous lecture, we talked about we gave an introduction to NumPy, and we tried using NumPy to solve a system of linear equations. Right now, today and in subsequent videos, we'll be learning how to solve a bunch of things. And as I told you that we'll be learning concepts in videos and then trying to use those concepts to solve chemical engineering problems. So that's what we are going to do. So in the next few videos, we'll be solving a particular problem which could be useful for chemical engineers. So that would be something like this. So I'll just set up the problem first, and we'll then try to solve this problem, right? So we'll be learning multiple concepts, and hopefully this is helpful. So let's start with that. So let us say we have a reaction of this kind. So we have A plus B gives C plus D. We have 1 mole of each to make it simple with respect to stoichiometry, right? You can do more complicated systems as well, but let's start with a very simple system right now, okay? Let's say this is a constant volume reaction. So it's a constant volume reaction. And because of this, we already know that the number of moles are always constant, right? And we'll also know, because of the fact that this is a constant volume reaction, we'll now know that we can divide the volume on both sides and we'll get the sum of concentrations as constant, right? And this can basically be equated to the initial concentrations. So that is Ca naught plus Cb naught plus Cc naught plus Cd naught, right? This is one of the conditions. Let's say the rate expression for this is of this form: K Ca to the power n, Cb to the power m, right? And after that, we are trying to get the data for concentration as a function of time, right? So that's what we are trying to do. We are trying to see how concentration changes with respect to time. And one thing that we know is that once we know the concentration of A, we can predict all the other concentrations by stoichiometry. So the only concentration that we are really interested in finding is the concentration of A. So how do we do that? And this we want to do for any number of time points. So it's not just for a fixed number of time points. So let's try to see how exactly we could do that, right? So first of all, let's start with the form in which I have data with me, right? So I'll maybe clear all of this and share my data with all of you. So the data that I have is in this form. I have concentration versus time data. I have concentrations of all the species, Ca, Cb, Cc, Cd, and I have time, right? I have times. Now, this data is available only till 2 time units, but let's say I want a more general data and I want it for many, many times. So how would I do that? How would I find my rate expression, basically? So we'll try to solve this problem in this video and the next subsequent videos. So today, what we want to do is we want to get this data from Excel to Python, right? That is our objective. So let's try to do that. So this section, or this thing where you try to get data from a file into your system is known, into Python, is known as file reading. So we are going to try and read this file, right? We are going to try and read this file. And for that, we'll be using something called as pandas. Pandas is another library like NumPy. So now we are all experts at installing these libraries. So pip install pandas. So that would help you install pandas in your computer. Since my system already contains pandas, so I don't really need that. So now I can import pandas as just like we import numpy as np, we'll import pandas as pd, right? And after that, we'll read this particular file. Okay, so to read this file, this is an Excel file over here. So I'll use something called as read Excel. There are multiple other options that you can use. We'll maybe cover some examples and you'll get more used to reading files further on. But right now, let's just go with it. So pd.read Excel. And after that, within these parentheses, you need to provide the address of this file. Okay. So to find the address of the file, so this is where my file is stored. So we could get the address of this file, the path of the file, as in this way. So to get the path of the file, you basically need to know which library it is stored in. So since I have a Mac over here, this is how I can do it. I can just click on the file, and then over here down, I can right click and copy concentration versus time data.xlsx as path name. This is what I can do. In Windows, you could right click and you could go to something called as properties, and in properties you'll get the path of the file, right? So you can copy it from there. One thing that often happens with Windows users is, so this is the path of the file that has been copied over here. One thing that often happens with Windows is that often this slash over here, it is copied as this backslash. So you don't want this. So this would always show you an error if you copy it this way. So once you copy the file name, after that, you can replace the backslash by this slash over here, right? So this is how you read the Excel. And of course, you need to store this in some variable. So let's call the variable df. Df stands for data frame. So we'll store this over here. So over here, I have a df. So now you see this has stored this entire thing as once again a matrix. But easier thing with this kind of reading using pandas is that all the headings, so over here in my Excel, the headings were time, CA, CB, CC, CD. All the headings have now been written as column names, right? So if I want to access the time column, I could just say, let's say A is equal to DF, and within square brackets, I could say T, right? So that's the column name. So as you can see over here, these are column names, right? So if I run this, I'll have stored A, right? So this is my A. This is how it has been, this is how my time values have been calculated, right? Have been brought into Python. And similarly, I could get my CA, CB, CC, CD. So I could, let me just write this as time itself. So similarly, CA could be this, CB could be this, and so on, right? So I've got these values over here. One thing that you see is that they've stored it as a series. So maybe you would want to store them as arrays. So we'll just write numpy.array, and sorry, I'm not importing numpy over here. So let's import numpy as np. So this converts this series into a numpy array. So now the time that you have, it is stored as numpy arrays. Similarly, we can store concentration data as numpy arrays, right? So this is what you can do. And now you can perform any kind of an operation on these time and concentration arrays as you feel like. So for example, if I want to say multiply the concentration array with 2, so I could do that, right? Similarly, if I want to divide it by 5, I could do that. If I want to add the time array to some 10, I could do that. So I can do all the operations, all the simple mathematical operations that we learned in the previous lecture, right? So in this video, I just want to focus on reading a file. So this is how you read an Excel file. There's another kind of file that is a CSV file, a comma separated value. So there's not much difference. Like the files that you store, they are usually stored as Excel files itself, but the only difference comes along is in its extension. So for example, this has the extension XLSX, but a CSV file has an extension .csv. And so there's not much difference when you read these files, but when you are writing these files, you can actually get the difference. So basically there you can separate values using commas, and you can then write the file. So when we'll talk about file writing, maybe in some other video, we'll talk about it. But right now we are just focusing on reading a file. So in order to read a CSV file, if you want to read that, uh, instead of saying .xlsx over here, it would become .csv. And instead of saying read Excel, it would rather be read CSV over here. Okay, so that's one more thing. And apart from that, this is, so in Excel, as we all know, we can have multiple sheets, right? So let's say I have another sheet over here. Okay, so let me just copy this over here. So I have copied my this thing over here, and let's just give them random names for now. Let's just give them this. So now if I read this data frame, it would still read the first sheet. But let's say I want to read the second sheet, right? So by default, it would always read the sheet that is sheet 1, but you can give a sheet name next to the path. So this is the path. This over here is the path, right? But after this, you can have a comma and you can write the sheet name. So if I write sheet 2, it would actually read the second sheet, right? So 1 second. Maybe I need to close this. Okay, sheet 2 has no spaces. So let's just remove the space from here. And it doesn't really have a time, but you may see the data frame has read A, B, C, D, E, right? So this has been able to read the second sheet, but we are not interested in the second sheet right now. So I'll just remove this, but or I could just say sheet 1 over here, and then it would read sheet 1, right? So this is how you read a file. You write the path name, comma, sheet name, right? That's all. Okay, so in the next video, we'll try to understand how to get the rate constant and the order of the reaction with respect to A and B using some of the NumPy functions that we learned so far. All right.